Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 290, I chat with Anthony Grimani and Manny LaCarrubba about their new speaker system. So stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Home Theater Geeks is provided by CacheFly at CacheFly.com.
This is Home Theater Geeks with Scott Wilkinson, recorded February 4th, 2016. Episode 290, 50 Ways to Love Your Speakers. This episode of Home Theater Geeks is brought to you by the Ring Video Doorbell. With Ring, you can see and talk to anyone at your door from anywhere in the world using your smartphone. It's like caller ID for your home. Right now, get free expedited FedEx shipping when you go to ring.com/HTG. Hey there, Scott Wilkinson here, the Home Theater Geek and editor of avsforum.com. This week's guest geeks are Anthony Grimani and Manny LaCarrubba of Grimani Systems, a new company that we're going to be talking about speakers today. Anthony, you've been on the show a number of times. Welcome back.
Well, I'm glad to be back. It's always fun.
Always great fun. And Manny, your first time on the show. Thanks for being here.
Yeah, thank you for having me.
Those of you who are tuned in live at live.twit.tv and logged into the chat room there, or at irc.twit.tv, can post questions for us as we go, and I'll pass along as many as I can. It's always best if you include my screen name, Scott Wilkinson, all one word, no dots or dashes, and then that'll appear in a different color on my screen, and I'll be able to see it more easily. So, like I said, Anthony, you've been on the show a number of times to talk about room acoustics, but today we're going to be talking about speakers. You teamed up with Manny on developing a brand new speaker and a whole speaker system, actually. So I'd like to start with Manny. And Manny, tell us a little bit about your background, how you came to be a speaker designer.
Let's see. I started getting interested in loudspeakers when I was in college. So I have a Tonmeister degree, sort of a Tonmeister light, because a real Tonmeister is like a doctoral level thing. But I have a BS in Tonmeister studies, and the guy who ran the program there, which was in middle of nowhere New York, Western New York, SUNY Fredonia, was a guy named David Moulton, and he had been working with a physics professor to try and solve this problem of directionality of high frequencies, right? So high frequencies tend to beam because the wavelengths are so short relative to the radiating element, and low frequencies don't have that problem. And that got me interested, but my training was as a recording engineer. And so I got out of college and I started working in as a sound contractor, on some very large scale sound systems, things like the Rose Bowl and the Candlestick Park, and we did a corporate boardroom for Apple Computer back in the late 80s, and ended up in a recording studio. And I spent most of my professional recording career at the plant studios in Sausalito, so the old Sausalito record plant, and ended up as chief engineer there, and all through in the background, I had been working on speaker design. And so whenever there were down days in the studio and things like that, I'd go into the big tracking room and set up for loudspeaker measurements. And, of course, was always involved in the design of the studios and the construction and the setting up and calibrating of the monitors. And so I was really close to all that. And that, long story short, it ended up with me partnering with my former college professor, and we're dear friends and business partners to this day, coming up with something called the acoustic lens, or acoustic lens technology, which I happened to dig out, this is like a 25-year-old clay model, like one of the very first ones I made, to sit on a tweeter, and the dome of the tweeter, let's see if I can hold it so the camera can, the tweeter goes right in here in this concave cavity here, and we ended up selling and licensing this to Bang & Olufsen, and they embodied it in a number of loudspeakers. I can call up some pictures here. Let me see if I can find a picture or two. But the first one, let me make this big. I'm not connected to the internet. No, you're right, I'm not. Oh, because when I saved these pictures, it saved them as not as downloaded files, but only the. Oh well. Anyway.
We certainly know about the Bang & Olufsen acoustic lens. That's
right. So that was my invention, and they embodied it, and so that's how I got into loudspeakers, sort of through the back door. I'm really a recording engineer, and setting up large-scale, recording studios, and got into loudspeaker design just because I loved it, really, and the thing with B&O was huge, of course. And
yeah, huge. Well, that development of the acoustic lens has, in fact, informed and influenced what you have designed since then and what we're going to be talking about today. But before we get to that, I'd love for Anthony to tell us a little bit about the mission statement, if you will, of your new company called Grimani Systems. Tony, you've been doing acoustics for a number of years, certainly acoustic treatments and so on. What led you to decide to get into building speakers and making speakers for home theater?
A number of things, actually. One of them is meeting Manny. I met him originally when I was working still at Lucasfilm THX, and Manny had come in and said, "Hey, I have this new speaker idea with this lens gizmo, and I'd like to see how it compares to the THX criteria, see if we can even get it THX certified." And I looked at it. Why don't you give me that lens over there? I looked at I looked at the speaker he brought in that had this thing in it. I think it was like the little two-way diapoliter.
Yeah,
that's
that's
right. Had this thing hung in the middle with a pair of woofers, and I was like,
I'm kind of liking that, huh?
Well, no, actually, first reaction was like,
what the heck is that?
Yeah, most people don't think that that's going to sound any good when they see it.
911, please send an ambulance and bring them to... So I was like, I actually am a little open-minded, and I said, okay, well, whatever. We'll look at this. We'll test it out. Fine. We put it up on the acoustic test lab we had over there, and it's like, wait a minute. He's got some frequency responses and some off-axis responses, things that were working very well, and that at first, by eye test, you would go, this is impossible. You can't get there from here. And so first step is that it actually measured pretty well. The next step was put it up and listen to this early implementation. It was like, wow, listen to this. It transcended a lot of what at the time, and I'm going back, what is this, almost 20 years now.
More than 20 years. This is about 20 years.
Our kids weren't even born by then.
That's right.
That's how long it is. So that opened my mind to, like, there's this guy over here who's doing something a little different and really interesting, and so then we stayed in touch through the years, and when it came time to look into some new speaker designs, Manny and I partnered up and said, well, let's take all of this body of work that came from doing this, and let's apply it to a larger scale, high sound pressure level home theater application. And Manny developed a generation 2 of this called the Conic section array, which we'll show pictures of later. So. One thing I'm not interested in doing is introducing just another speaker to the market. The common thing we always joke about in the industry is the audio market needs another speaker brand like it needs a hole in the head. No thanks. But Manny has this amazing invention in the Conic section array that transcends what we're used to hearing and seeing and experiencing out of loudspeakers. So it was like, somehow we have to bring this out to the world, out of the lab and into the world. So that was one concept. The second thing I think that drove the startup of this company was a little frustration about the fact that the speaker industry really hadn't evolved very much, and that we kept having to work as design engineers with the same technologies, the same sausage, the same kind of recipe as forever. And I actually have a slide. I think that I put up the last time I was here, but I'm going to ask if we can put that up. So if we can go to number 16, I think. I'll put this up on the screen. The reality about home theater is that in the video part of home theater, video technology has evolved a huge amount in the last 50 years. We've gone from small black and white TV sets to 4K ultra high def 3D for about the same price given the cost of living increase. And along the way, we've gone through color and projection TV and plasma and all these things. But look at how far we've gone from here to here. Mm-hmm. And then if you look at the speaker business, well, from 1966 to 2016, it's basically about the same. Driver technology has definitely improved. The cabinets have changed in style. Largely, this is still a box with drivers and a passive crossover that you connect a pair of bare wires in the back of and, cinch them down and hope it's all going to work. And so, whatever. If it's not a problem, it's not a problem. But what we found is in the context of large-scale, custom-installed home theater systems where you have 3 of such speakers across the front, 2 or 4 or 6 on the side for a bigger room, 2 in the back, and then maybe 4 on the ceiling, and extra wide speakers if you're doing Atmos, and 4 subwoofers, all of what used to be acceptable as a paradigm in the world of 2-channel stereo, which is these, basic speakers with bare wires plugged into the back, becomes a nightmare in the world of home theater. And it's a nightmare because you have so many points of contact. You have surround processors hooked up into equalizers and crossovers and amplifiers and speaker wires and stuff that goes everywhere that ultimately actually never works right. So
there were a ton of problems. In fact, you've alluded to them, and one of your favorite points, my favorite points that you make is about there being these 50 problems and those are only the top 50.
The most common 50. I'll get back to that later. There's a great slide for that. But
all right.
So impetus number 1 is there's this guy over here who's developed an amazing way to produce mid and high frequency in a listening room that is amazing. It's like the best ice cream you've ever tasted. You want everybody else to taste it, right? Chocolate with bacon in it. Oh my God! I mean, it's unbelievable.
That is kind of a thing these days.
It is.
Yes, I am a chocolate addict. I admit it. So, Manny has this great speaker. 2, we're frustrated with the fact that things are still kind of low tech in how speakers are done, and it's okay as long as you're just doing enthusiast-based home 2-channel audio. But when you're trying to install a properly running, custom-installed, multi-channel audio system with Atmos, it gets too complicated. Number 3, I think, in what drove the interest was that we actually partnered up with a funding source, somebody who said, I like what you guys are doing. I'd like to invest in what you guys are up to. And we found the money, which was amazing. So an angel investor came from the skies and said, let's fund this, let's develop this. Without those 3 things, I would have never gone into this business. I would have just kept doing what I'm doing. So we've developed a mission statement about why we want to do this, and if we can, thank you very much. Yeah, the engineer here is very good, unbelievable. So here's our mission statement. Numero 1 is we want to deliver the artistic intent with great precision. Now, I hear a lot of people say that, what is the artistic intent? The point is that Manny has spent 25, 30 years of his life.
I still mix and master occasionally in my studio to this day. I just finished a jazz record for a friend. And so, timbral accuracy is absolutely paramount for me. I insist that everything I do be just really very, very accurate. And this goes way back into my recording studio days. I'd get, visiting engineers would come up from LA and things like that and go, man, who tuned the monitors in here? This is awesome, And so, and I would get feedback from these guys, and it led to a whole process of tuning loudspeakers and audio systems that, I use today and has been very, very, very successful. And so that's sort of the background there.
Mm-hmm. Mm-hmm.
So Manny he has an experience of what the artistic intent is. He's been in the studio with famous acts saying, this is the sound. And we want to bring that sound out to people in their homes. I have experience from the film sound side, 5 years at Dolby, 10 years at Lucasfilm THX, working in and around the studios over there. I have a very good idea of what they're hearing when they're mixing the movies. And our mission is to bring that to people. without any change, without any more sugar, without any more bass, without any more, just what it's supposed to be. You may like it, you may not like it, but this is what the artist intended to be heard.
Certainly, I always find that I always make that point with video, is I want the video system to reproduce what the creators intended in terms of colors and grayscale and brightness and so on like that. So
correct.
It's a very similar thing here.
It's absolutely identical. The amazing and beautiful part of video is that the vectors, the actual test processes, are very clearly documented, written by the forefathers of video, with unbelievable smarts in how to define the color, the grayscale, and measurement tools that go, if you have A plus B, you will get C, and it actually looks right. Audio is a little bit more amorphous, because the measurement methodologies out there are still, I don't want to say nascent, but are still we're still trying to develop measurement systems that once you actually get data, it actually sounds that way. And we're getting better at that. There's been a lot of developments on that, but it's a little bit more amorphous. Anyway, so delivering the artistic intent is something I would say a number of people have achieved in the past, but it's always been really difficult. We want to do that while it being easy to set up. We don't want to make this a science project every time. We also want it to be robust. So after we get done setting up a sound system for multi-channel audio, whether it's for home cinema or a screening room or whatever, we want it to stay that way and be robust and be user-friendly. Along the way, we want to use as much new school technologies as are available, and not just go, well, you know, it worked fine this way for the last 30 years. Why improve? Well, why improve? Because there are some really cool things you can do today with the Internet of Things, we'll talk about that later, that make the product provide a lot higher value than the current crop of audio systems out there. So that's our mission. Sounds like
a fine mission. Let's talk about how you're going to actually achieve it. Is this the point to talk maybe about the 50 problems?
We can go there.
We could do that. Yeah.
I just want to. This is such an interesting thing that I just want to touch upon it. You've got this long list of 50 problems that you're trying to solve.
It's interesting. When Tony first sort of dragged me into this industry, high-end custom installed theaters is what Tony's consulting company has done for quite some time now. I was sort of new to it. I didn't even have a home theater set up in my house, and Tony, really needed to go visit what was to be his new in-laws in Argentina, and needed somebody who could he could send out into the field while he was gone to, stand in front of a large-scale audio system and do something intelligent. And he warned me about all these things that would come up, and I'm like, come on, these guys can't be that bad. And I don't mean to razz the integrators, but it's really hard to set up these systems that Tony was describing earlier and get every last XLR connected in phase and not miss something. And I was sort of stunned. I started to go out and do these calibrations on cinema systems, and it's like, man, we'd spend all day fixing problems and ground hums and things like that, and that were sort of beyond the capabilities of your average install guy, and because it does get very complicated. And so I was kind of stunned, and that was sort of the genesis of a lot of what we're doing here now with Grimani systems, and where this list comes from that Tony's going to talk about.
Well, before you do, I just want to say that Barfel made a great point in the chat room. I've always said that I like a great picture as much as anyone, but to make the hair on the back of my neck stand up takes great sound.
Yes, it does.
Yep.
And I think that's probably true. I would have to agree with that. As much of a video person as I am, I'm also an audio person, and it's the sound that can have more emotional impact, I think, than the video. Right.
Sound is definitely the emotional part. There's the obvious one everybody talks about, which is the sound of the tum 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 before the shark shows up. I mean, everybody recognizes that as the shark is about to come over and eat your leg. And I think we talked about this at the last time we were here. You can, if you're really good with a picture, create an emotion, but it's a lot easier with music. And think of, I think of Tchaikovsky, and Tchaikovsky has the ability, or Chopin has the ability to put out sounds that I just want to cry and eat some chocolate.
With bacon.
Yeah, with bacon.
With bacon.
Somebody said they can't do more than 60%. I found 95% in Europe. It's pretty heavy duty. But
Oh
it's,
my
it's
God.
Good. It's good if it's
Well, we'll have to do a special show on chocolate sometime.
I'm noticing that Mike Heiss, Dr. Heiss, hello,
Yes.
asked about the measurement methods developed by Floyd Toole at Harman. They are crucial. The work of Floyd Toole has been fundamental, crucial, very important in a way. Some of the charts we're going to show a little later are right down the road of going, look, Floyd said, here's some good things to do, and look, we did that. It's like, if we had to turn in our homework paper to Floyd, he'd go, A+.
Floyd is the reason that there is an acoustic lens, as a matter of fact. So
No kidding.
Yeah, there's a great story here. I owe Floyd an immeasurable debt. But in the late it must have been like 1989 or 1990 at the latest or something. So my partner Dave and I went to the NRC, the National Research Council in Canada, in Ottawa, with a perfectly awful pair of loudspeakers that I had developed that used the precursor to this device, which was something called the Ferrolips. I don't have a picture of that anyway, but it was a very unusual looking thing that used two tweeters. And so we went through the whole testing process, and we actually did all the blind listening trials in the same rooms that he did all his original tests that all those seminal papers came out of. And we basically told ourselves that our loudspeakers sucked. And as we were saying goodbye, Floyd, tried to give me some nice fatherly advice and say, I doubt that such a thing could be made to work. And I was just too young and stupid to know who I was talking to. And I just took that as a challenge that I am going to make this work. And that is what forced me to invent this widget, and that's where that came from, as a direct result of Floyd saying it probably can't be done.
Wow.
Yeah.
That's a great story.
It is.
Great story.
I've told him that too.
I'll have to, Floyd's been on the show before, actually, and hasn't been for a long time, so I think it's about time to get him back.
Absolutely. He's a great guy.
So all this to say that a lot of our actually, a lot of our measurement technology, our methodology follows what the NRC and then subsequently Harman research has been doing. And a lot of the theories of what Floyd has worked are applied into the design of these speakers. I guess one way to represent what Manny did is he has found a way to implement Floyd's theories in this waveguide. It basically is a really simple way to put it.
I actually have a chart I want to bring up in a second. Let me enlarge this a little bit so we can see it a little more clearly. This is what I've come to call the Harman curves. And this data is from a prototype loudspeaker. Sausalito Audio is my company, separate from Grimani Systems. And before we started on this adventure with Grimani Systems, I got interested in the idea of applying this sort of very wide dispersion to PA speakers, to sound reinforcement. My wife is a singer-songwriter, and she's been performing for years, and I've built some prototypes in the past, and I built this rather large-scale prototype using the new CSA. At the time it was a new thing, and this data is from that, and this is the sort of set of measurements that Floyd, particularly at Harman, of course in conjunction with Sean Olive, who was a graduate student and helping us out in that earlier story, and Sean's a great guy as well. At any rate, I want to just call this out. So this set of curves is what Harman holds up, and through Floyd's research over decades, as really being pretty good, marker for sound quality. And now this is a PA speaker. It uses two. I'll bring up a picture in a minute. It uses two 10-inch drivers. It's a 2.5-way design, which means the upper 10-inch driver is crossed over to the high frequency unit, but the lower driver only goes up to about 500 or 600 hertz, but they both go all the way down. So what you see here, this red curve is the axial response. This is the reference axis of the speaker if you stand in front of it. And this green curve is a listening window. So if you take 60 degrees to one side over to 60 degrees to the other side, and up some number of degrees vertically
30.
and down vertically, you're going to get this average set of response. When you average those together, you get this set of responses.
30 to one side.
No, 60.
All the way up to 60?
This is all the way
Wow.
out to 60 degrees. Let me verify that. I can.
You can tweak this in a second.
I can't see that very well. Does that say 60 in there? My eyes aren't good enough. 0, 30, 60. Yes, that listening window goes out to 60 degrees. So this is 120 degrees of coverage angle represented by that
that
green
seems like
curve.
an awfully wide window.
But you see, in sound reinforcement, this is what you need.
It's
right?
very important. I totally agree.
You
totally
walk
agree.
into a bar, there's the singer sitting, they moved a couple of tables aside, and they're against the wall, there's people from there to there, and or you're at a street festival or farmer's market, whatever, that's where people are. And this is the sound power. This is, 72 measurements, what Harman has come to call the spinorama. So you make, measurements all the way around in both axes. And then this bottom curve is this red curve minus this sound power, and it gives you a directivity index. So what I want to do now is to bring up a very good but traditional loudspeaker. This is the industry standard speaker that I'm going to have up here in a second. No, I don't want to move it. I want to make it bigger. So this is a standard 12-inch two-way loudspeaker made by QSC. I own one. My wife plays with this. It's a very good loudspeaker. But you see the effect of what happens when you have too big a woofer. This is a 12-inch driver crossed over somewhere close to 2 kilohertz, mated to probably a 90 by 90 horn, all right? And so here's the axial response if you stand in front of it, and here's that same window. Look at the delta between those.
Right, and there's a huge dip at, I can't see what frequency that is.
This is about
but
2 kilohertz, right? Because that 12-inch woofer is beaming like crazy. And this is very illustrative. I mean, they're trying to optimize. I mean, you can buy this thing for $600-700 at Guitar Center, right? So it's not a particularly expensive speaker. It happens to be very good at what it does. It plays very loud, it don't break, and it don't cost too much. And so that's pretty good.
Thus, it's very popular.
And it's very popular. It's easily the most popular PA speaker. And I bring this up because this is what happens to varying degrees, not just in PA speakers, but in consumer audio speakers sold for music playback or cinema use. If you use too big a driver, crossed over too high, you get that kind of anomaly in the windowed response, and you get too high a directivity, and you get a directivity that varies with frequency. None of which is particularly good for the high quality audio.
Especially for anybody sitting anywhere but in the sweet spot.
Well, that's true, but it goes far beyond just sitting in the sweet spot, because what happens when you're sitting in the sweet spot, when you have a very well-designed loudspeaker, and I'm taking that to mean a speaker that doesn't have anomalies in its power response or its directivity response. And so, and good broad dispersion, right? This in any number of listening tests, these are the speakers that routinely get the top marks. They have broad dispersion, it's very uniform, they have extended bass response, extended treble, low distortion. You hit all those marks, and you're going to have a great sounding loudspeaker. You can't not, really. And but I bring this curve up because it shows this is an extreme example. You generally wouldn't do this in consumer audio, but for purposes of power handling that come up in sound reinforcement. So it exaggerates it, but you have this problem to varying degrees in all loudspeakers. And that's the problem that we set out to solve, and largely did.
Creamy Corncob asked if that speaker had a crossover at 5 kilohertz. No, it's around 2 kilohertz for that particular
This
PA
one here,
speaker.
Which speaker?
The one you just had up. I think that was.
Yeah, the QSC is around 2
it's around
kilohertz.
2K. The point, Scott and everybody else, is that when you have a speaker that has varying directivity like this, that starts wide and then beams and then opens up, is the room response is a mismatch to what the direct sound is. And what you hear when you're in the room is, of course, some direct sound and reflected sounds. So you get this summation of what may be a correct axial response together with a bunch of off-axis response that's totally wrong. And in the end, it's bad sound. Unless you're in an anechoic chamber or a bar that has 6 feet of fiberglass or foam all the way around it, which I've never seen.
Nope.
No.
Nor would I want an anechoic chamber for my home theater.
Nor would you want that. So whether it's a bar, a home theater, a listening room, there's always sound reflected off of the walls. It contributes to, actually, in reality, the majority of the sound that goes into your ear is reflected energy, because there's only one vector of sound that goes to your head, and everything else is going everywhere else. And so it is really important to have a speaker that has good direct sound and also good off-axis sound. Off-axis being one that doesn't have big, huge accidents. And I'm going to show you some charts of more speakers that are known industry standards, and then what we've done. So you can see here's, typical successful speaker that's considered state-of-the-art, and then now let's take a look at how we've been able to advance that state-of-the-art. Meanwhile, I found my slide of 50 reasons why. Okay, read them all, done.
I love that slide.
So we, of course, don't have time to get into all of that, but what I have to do is to go pick one number randomly from 1 to 50. I think we did this last time, Scott. Do you want to get into that, or do you want to just move on?
Well, we did it at CEDIA, and this is where I first heard your speakers, which, by the way, I have to say, I and many of my colleagues said of your speaker system at CEDIA, best sound at the show. So there is really something to be said for what you're doing. Yeah, for now, I think we should move on.
Great.
Because we have so much else to cover.
Great.
As much fun as that would be, let's move on. In fact, while we have a moment here, let me just give you a breather. You guys have been working really hard and been really great. Lots of good information. But for a moment, let me thank our sponsor for this episode, which is Ring Video Doorbell. Now, we're all familiar with the sound of a doorbell, of course. We're talking about sound here today, and whether or not it's live or over a speaker, you know what a doorbell sounds like. It means a package is being delivered or friends are coming over for dinner. But it's also the sound of someone planning to rob you. Over 95% of home break-ins happen during the day, and burglars almost always start by ringing your doorbell to see if someone's home before pillaging your possessions. Well, with Ring Video Doorbell, you can see and talk to anyone at your door from anywhere in the world using your smartphone. Ring's advanced motion detection alerts you even if somebody doesn't ring the doorbell. With Ring Video Doorbell, you can talk to delivery people, keep an eye on your package. If someone tries to mess with it, you'll get an instant alert and HD video of the whole thing. It's like having a neighbor keep an eye on your home 24/7. Now, I recently got a Ring Video Doorbell and found it so easy to set up. It was really quite easy and amazing. You download an app into your smartphone, you set it up with the Ring doorbell on your home network, and boom, it's done. Every time the doorbell rings or the motion detector gets set off, you get an alert on your phone, and you can answer the door and say, hello, hey. And if someone looks suspicious, you can say, well, I'm in the back right now. I can't really talk, even if you're somewhere else in the world. Really, it's really quite astonishing. Installing Ring takes only minutes, and it works with either your current wiring or a built-in rechargeable battery. So put your mind at ease and protect your home with the Video Doorbell. Time magazine and USA Today named one of their top 10 gadgets of 2015. Go to ring.com/HTG for free expedited FedEx shipping. That's ring.com/HTG. With Ring, you are always at home. And we thank Ring very much for their support of Home Theater Geeks. Okay, so I'm talking with Anthony Grimani and Manny LaCarrubba of Grimani Systems about their new speakers that they have developed. Manny, in particular, went even further than the acoustic lens idea to make something called the Conic section array. And Tony, I think you were about to go on to something that we wanted to talk about.
Yep, I just wanted to show some graphics that illustrate what Manny was just talking about. I have some, you know how much I love these motion PowerPoints. So let me indulge for a second. We were talking about frequency response. We all know that to get a speaker to sound good, it should have smooth on-axis response. Many of us knew it should also have smooth off-axis response. That's been known for a very, very long time. If you were to chart it, it would look something like this, where the green would be the axis response. And what you'll find in most speakers is that the off-axis response has some accidents in it. It's not very smooth in most speakers. Now, to be clear about what I'm calling the axial response, this is a top view of a home cinema with a 7-channel layout, 3 fronts, 2 sides, 2 backs, and a listener with a receding hairline in the middle. And that's me.
I'm sorry, me too.
Yeah, that's
we're all
the reality. So the axial response is basically just the sound that's going from the speaker to the listener, and that should be as smooth as possible. The off-axis response, this blue line, is what goes somewhere else in the room, and on many speakers, there's an attempt at making it smooth, but it usually looks a little bit rough. Now, what you're actually hearing in a room is a combination of the direct sound plus some reflections. And I'm just going to show you some reflections off the right wall. Like this one bounces a bunch around before it gets to you. This other one that's about 20 degrees off axis bounces around. This other one bounces around, gets to you. Eventually, all these off axis sounds that fan out of the speaker eventually get to your ear. This shows the reflections off what would be the right side of the speaker when you look at it. This shows the reflections from the other side.
Holy smokes.
The point of this chaotic drawing is to show that you're listening to one direct vector and then a whole bunch of these red reflected vectors that are later and a little quieter, but overall what goes into your ear canal in a typical home theater, typical listening room, is more of this stuff than that stuff in terms of just net sound power. So that term, sound power, doesn't mean watts. We're used to, thinking of power as the bill you pay every month, to cover the cost of your hot tub. But really, in the term of art and acoustics, that means the net energy in the room, the net sound pressure in the room. So understand first is that you're listening to a lot of all of this. So it goes without saying that all of that should be nice and smooth. Now, directivity in a speaker is important. You hear more reflected sounds in a room than the direct sound. The sound returned from the room should match the direct sound as much as possible, but most speakers have a variable dispersion. This is what Manny was talking about. So most speakers radiate evenly in all directions at low frequency. Somewhere in the mid-frequency, they start to beam forward, and somewhere in the high frequency, they beam a lot. And then between all of those, it also changes back and forth. So you could actually have a radiation like this at a kilohertz, and by the time you get to 2 kilohertz, it could get narrower, and then it widens out and it gets narrower. That all means that the sound power is not smooth, and that's because how typical cone and dome speakers are built. Flat axial response, and the radiation depends on frequency. The net result of it is a typical 2- or 3-way cone and dome speaker has a sound power that looks typically like this. We call that that it's tilted down because the off-axis energy is missing compared to the direct sound. So this is a chart that Manny plotted of a typical, we won't mention any ways, but it's a typical 2-way speaker with a waveguide, well known in the industry.
This is a very good speaker, by the way. This is a professional studio monitor that I would recommend I would buy if I needed to buy such a thing. It's a very good 8-inch 2-way.
Okay.
So in the speaker, the axial response is the one in blue. It goes up rising a little bit, a little bit on the bright side, whatever. 30 degrees looks like this. So it's losing a little bit of energy. This is 5 dB per division. So it's down to 3 dB, all perfectly acceptable. By the time you get to 60 degrees, you're down about 5 or 6 dB. By the time you get to 90 degrees, look at that. This is 5, 10, 15. So at 90 degrees off axis, the speaker's radiating 15 dB less sound than direct. And you go, well, who cares? Nobody's listening there. Well, the room is listening, and the room is returning that sound back to you. So the room is getting a combination the room is getting a combination of some of this blue line and a bunch of the red and the green and the pink, and the net result is the sound power that Manny showed in his charts before. Now, Manny's been working on this and came up with a conic section array, which is a revolution, like we say. It's got true constant directivity, wide horizontal dispersion, high efficiency. It's an audiophile box, and it's different in that the driver unit, the little thing that moves air, is
actually vibrates. Yeah,
it actually vibrates air, is transversal. It's not in the back of the throat. It actually points up into the waveguide, and the waveguide coerces the waves to go in the right place. We call that controlled distribution. So the idea ultimately is, if you look at it from the top, is it radiates evenly in all directions at all frequencies.
At all frequencies it covers.
Of course, yes.
And in the case of the waveguide that Manny is going to show in a second, it covers from 1 kilohertz to, you know, the higher frequencies, around 16, 17, 18.
Yeah, now up to about 18 kilohertz is what this is an early prototype of what we're using. I'm trying to get some light in there, but I have a picture on the computer. Maybe it's easier to see, but the compression driver would mount here on this plate and point up into this throat here, and then this is the mouth of the waveguide here, and with that geometry we're able to get extraordinarily wide horizontal coverage with some varying vertical. You sort of steal from the vertical Peter to pay the horizontal Paul, is the way I like to put it. But the power of this, I have a good anecdote. Go ahead, Scott. I'm sorry.
I'm sorry. I was just going to say that I find this so brilliant that as you have said during the show, that high frequencies tend to be very beamy. They tend to be very directional. Right. And yet you have created this way of pointing them upwards, and they fold over into this wide expanse and shoot out in all directions evenly. You've solved the problem of directivity of high frequencies. It's really brilliant.
Well, thank you. Yeah, very largely we have. Yeah, it's kind of neat. I want to tell one anecdote, and I got one slide I'd like to show.
Sure.
The importance of what Tony was just saying. During the development of the BioLab 5 in Denmark at Bang & Olufsen, Bang & Olufsen has a listening panel that they use as calibrated. They use people as calibrated test instruments. So these people have to go in every week, and they have to listen to some unknown speaker behind a screen, and they make their comments, and they make sure that they're saying the same thing about the same speaker every time they're presented with that stimulus. And they went as far as developing, just like sommeliers have words that they use to talk about wine. There's the wine wheel, right? They developed a similar thing for words around loudspeaker quality, and so one of these guys stopped the test. He was listening to an early prototype, or actually a fairly developed prototype of what became the BioLab 5, and he stopped the test and said, "You're having me on. There's a real guitar player behind the screen. I'm not falling for it."
Wow!
He honestly believed there was a guy playing with solo acoustic guitar, like classical guitar. So anyway, Tony wants to show something. He's giving me hand signs here.
So the rubbing Peter, the bait Paul, and all of that leads to a consistent sound quality at all seats, and leads to the direct sound and the room reflections being matched,
right,
which ultimately is known to provide smoother sound quality, and that is the holy grail in loudspeaker design. Now, here's the charts. So the science ultimately comes up and reveals that, Manny's handiwork. So what is all this mess of all these colors? These are measurements of the waveguide that goes in the big speaker, the alpha, at 0 degrees. These are all 10 degree.
These are all 10-degree intervals.
So each one of these colors means, 0, 10, 20, 30, 40, 50. And look at this. Over 5 dB of range, the axial response, which is buried somewhere in there, all the way out to 90 degrees. Look at how smooth this is. It's not tilted in any way. It almost just looks like Manny tricked us all and just turned the level down, and not so. It really is remarkably smooth and even all the way up in frequency. And that's the holy grail. That's how you get a speaker to sound good and sound more consistent room by room.
Right.
this picture just shows actually the evolution of things. This is the first generation of the Waveguide that Manny designed and is used by Bang & Olufsen in their loudspeakers and some of the cars they license out there. And then this is the newer generation, they call the CSA, the Conic section array used in our speakers. And this is a graphic of it, what Manny was just holding up. This, hello, my computer has stopped reacting. Well, okay. Well,
oh, no!
Oh, no. Well, there's a couple of, somebody mentioned the Stag Theater on the chat room. And I actually did some measurements.
That, by the way, is the Stag Theater is the theater at Skywalker Ranch, which is a fabulous theater. I mean, I've actually been in it. I haven't watched a movie in it, but it's supposed to be where George Lucas and people who are making films, go to hear what they're doing and see what they're doing.
It's a reference theater, and
it's a reference theater.
It's for everybody who's doing their blockbuster sound mixes and film production out at Skywalker Ranch uses that theater for the final QC. So I'm friendly with one of the engineers out there, and we spent a couple of days measuring an alpha, the speaker that Tony was just showing. And what we did was we set up speakers on the stage, one next to the other. And then we measured each seat position starting. So this curve, this is showing seats 1 through 10. So 10, or seat 1 being off maybe on the far right or left, I can't remember. But often, the worst seat in the theater, front row, way on the edge. And then moving towards the center. And this speaker is from Meyer. It's the Meyer Ashron. This is an exceptional loudspeaker.
Oh, yeah, Meyer sound, great speakers.
Absolutely exceptional. The absolute best implementation of conventional horn design you're likely to see. And so this is what happens if you normalize the seat position. So you take the sweet spot in the center of the theater, and we'll make that this perfectly flat blue line here. And then we move over seat by seat until we get 10 seats over. The theater is about 20 seats wide, 21 seats wide maybe. And so seat 10, you're off on the far side. And this is the fall off that you get as you move down seat by seat, moving the microphone. And so now I'm going to show you this set of curves, which is the same measurements made with the alpha loudspeaker. And so you see how tightly clustered everything is. And in fact, it's an interesting, quirk of the Conic section array. It actually works in reverse. You get a little more extreme high frequency output here above 10K off axis than you do on axis. And with the other curves that Tony showed that are so flat as you move, that's a newer that's the next generation. This is a pre-production waveguide. And what you see in this area here, the crossover point is at 1 kilohertz, and you can see how even that 6-inch woofer, it uses a pair of 6-inch mid-range drivers, are starting to beam at the crossover point. But the waveguide is also beaming, if you will, about the same amount. But the difference in intelligibility in speech is stunning, because this whole region in this, between 2 and 5 kilohertz is dramatically different when you're off axis than this set of curves. Right? There's a huge difference. That's extremely audible. So it plays a big role. It's a big effect, and most people, quite frankly, aren't prepared to I say, come listen to my speaker, and they're like, oh man, do I really have to go hear another speaker? Well, you probably experienced that yourself. I mean, you're being polite to Tony at Cedia, and probably, and I'm guessing that you weren't quite prepared for what you experienced.
Well, that is in fact true. I mean, I did want to go hear the speaker, and Tony's a friend, and so I wanted to make sure to go say hi, and yet when I got there and heard things, I was like, wow, that's really something.
Yeah, it's different.
Yeah. Now, Creamy Corncob in the chat room had a question a while ago, and Tony, you were talking about room acoustics and sounds reflecting around and so on and so forth. And I'm looking for the question here. Here it is. With a 20 hertz wavelength being roughly 50 feet, more or less, how do you dampen a room while avoiding creating dead spots in the listening environment? This is a room acoustics question more than
Room
a speaker
acoustics.
question.
So at 20 hertz, right?
Mm-hmm.
So there's a whole bunch of different ways to do that, including not worry about it, because depending on the size.
Yeah, in a small room, there's no problem at 20 hertz.
At 20
Yeah,
hertz, at 20 hertz in a typical room, the wave is so much bigger than the room that there won't be resonances. You do have to worry about 50, 60, 70 hertz, but at 20 hertz, the wave, this is kind of confusing, but the wave is so much longer that it won't actually create standing waves, which is, some people go, how do you get bass in a small room? Well, how do you get bass in a car? Think about it. You're below the modal frequency, below the resonance frequency, and everything is fine. You get nice, tight, punchy bass. Problems happen is when the wavelength is either the same length as the room or twice as long as the room. Then you get into all kinds of problems. So the solutions at that, let's say 50 hertz in a typical 20-foot room. Solutions include building a room with single layer sheetrock on studs, maybe even metal studs that are slightly flexible so that the boundaries are not rigid. If the boundaries are not rigid, the standing wave doesn't stay in the room as tight. That's one. Two, you can build bass traps. You can put things in the room that are going to convert the acoustic energy into typically heat or other mechanical energies that are tuned to 50 hertz. And three, you can put 4 subwoofers in the room, either in the 4 corners, at the 4 25% points or midpoints in the room, and tune them in level, delay, and frequency response to essentially contradict the standing waves. And that's a lot of that comes from work also done under Floyd's group at Harman Research. And we practice all of the above to get the bass to be really tight in small rooms. Really, really important. It's all about the bass. It's all about the bass. It's really important for the bass to be tight, not have peaks and dips, not have holes, because that's sort of the foundation of the entire spectrum of what you're listening to. So we put a lot of energy into that, and our systems sell actually with 4 subwoofers, either 4 small ones or 4 big ones, depending on the room size, and then we tune them until the bass is smooth throughout the entire listening area.
Yeah,
Well, that's an... Sorry, Manny, go ahead.
No, I was going to just chime in there. Something like 30 or 40% of your perceived sound, perception of sound quality comes from the quality of the bass. It's huge. It's the single most important thing in how you're going to perceive, overall sound quality in a loudspeaker system. It's a very interesting. Sean Olive, actually, at Harman, did some neural network models, and he found that the contribution by the low frequency parameters was, I think, 30 or even 40%. It's huge.
Yeah, it seems similar to in video how having good blacks, how being able to resolve all the way down to blacks has an impression on everything else in the video, even though it has nothing to do with the color or the peak white. So it's kind of an analogous for you vidiots out there.
Oh, yeah. Very good, very good. Of which I count myself.
Yeah, I'm a video too, a little bit. Along with chocolate, I like dark chocolate. I like dark video.
Yeah, there you go.
With bacon. Okay.
With bacon, yes.
When we were talking about the show, you said, "Hey, bring some pictures of an installation," and I actually have some here. If you want to go.
Oh
there.
yeah, absolutely. In fact, that was my next question.
Well,
was you actually send? You actually, you have the speaker, but you actually sell entire packages.
Right.
Not, I mean, I suppose if someone wanted to buy 2 of these speakers or whatever, you'd probably sell them to them. But what you really want to do is create an entire environment which uses these speakers, acoustic treatments, and 4 subwoofers, as you said. So tell us a little bit about that.
So here's an example of a recent home cinema installation that's made out of a combination of our big bad boy alpha speaker, our flamethrower, whatever you want to call it. This thing plays about 125 dB, and a combination with a number of the smaller speaker called the beta, which was just officially tested at 113.
Yeah, 113, 115.
113 dB. We just sent all of this to a test lab in the Pacific Northwest. It's built into a decommissioned or never commissioned nuclear power plant, inside of which they built a test lab. Very quiet, minus 25 dB noise floor. So in there, we just got the measurement results, and the guy who runs the test chamber said, "This was one of the best speakers I've ever measured, and it plays 113 dB. Oh my goodness." So it's all good. So this is the actual room installed with 3 of the alphas, 6 of the betas, 4 of the delta subwoofers, and you'll see on the side over here these things on the walls that are acoustical controlled devices. This is a diffuser. These are absorbers. In our full package, we include speakers and acoustical treatments, and an engineered design service and a calibration service, because that's what makes up the whole audio system. It's not just a speaker, it's the whole thing. It takes the whole thing to get good sound quality. This is a picture of the completed room from the other side, but and this is looking backwards. Now, ordinarily, a room like this, all of these gizmos on the wall would be covered by stretch fabric. We don't really believe in showing all of this stuff. It's great for us geeks, but the average person doesn't necessarily want to see that in this room. So here's some pictures of mid-construction. Here, the room's been painted. It's been built to be sound isolated. Up here, what looks to be a number of wood structures actually for a coffered ceiling is actually stretch fabric that's hiding the ceiling speakers for Atmos and also hiding some subwoofers up there. And on the wall, these little black bars are where we're going to hang absorbers and diffusers down the line. Here you see the 3 alphas covered in plastic because construction's still going on. We don't want to destroy anything. And the screen's going to go up around here when it's finally built up. This is installing the panels on the walls. This is the speakers before the screen goes up. Now here's the screen. And voila, the room is all complete. There are about another 3,000 pictures of that construction, and I'm not going to bore you with the details.
Well, I think that's probably wise, but we got a sense there.
Yeah.
One interesting thing I've always found about this is that you know, these speakers are more or less designed to be hidden.
Correct.
Right?
Yeah.
They're very interesting looking, I think, but I'm not sure you would. You know, they have a very high spousal acceptance factor, maybe.
Yeah, the partner acceptance factor is an issue. We also believe in hiding the gear, both for just 2-channel music listening and for movies. Ideally, the whole experience of listening to a great piece of music should transcend the gear. And watching a movie, the experience of traveling over to Pitcairn Island, for example, you know, in the Bounty, you should transcend the gear. And if you hide the loudspeakers, it's easier to believe that you're in the movie. If they're visible, your conscious mind still registers that there's gear around you. So we like to hide it for 2 reasons. Design factor, whoever decides whether it's the spouse, the friend, the partner, or yourself, as well as the whole experience of traveling into the movie. So we believe in hiding it, and we design the speakers in a way to be matte black. Interesting enough, but not really a big showy thing, because we're assuming the fronts are going to be hidden behind the screen, and the sides and backs and ceilings will all be hidden behind a stretch fabric layer. We are working on an in-room version of the speaker. A number of the dealers we work with said, you know, I really would love to have something that I can just plump a pair of them in the room and make a beauty statement. And we are working on that. So look for it in the next 6 or 7 months or so.
We're hoping.
Maybe by CEDIA.
Maybe by CEDIA, yeah.
Yeah, okay. And another critical factor, I think, here is how the whole system connects together.
Yeah.
Which is pretty interesting. Tell us about that.
Yeah, we borrowed very heavily from the, you know, my background, of course, is professional audio, right? And in that world, we went to active loudspeakers a long time ago. Right, it's just a better way to build a speaker. It's almost hard to find a studio monitor that's not powered these days. And in the world of touring sound, everything has got to be, you know, networked together. It makes it so much easier, faster to set up large-scale sound systems and to have them be trouble-free the first time out. And so we just borrowed, you know, some best practices from related industries to bring to this industry to make it just simpler to set up. So we hook up, you know, we run AES digital audio over the unused pairs in a Cat5 or Cat6 cable, and that's it. One wire, plug it into the wall, done. If you can crimp an RJ45 connector on the end of a wire, you can hook up the system without anything else. So it's pretty cool. Tony's got a little slide here to show how the system interconnects, actually.
So yeah, this is a connection diagram. This would be your sources, Blu-ray player, whatever else goes into the surround processor and adapter. Out of that comes all Cat5 or Cat6 or Cat7 cable. Plug it into each speaker. Plug the speaker into a power source, and like Manny said, bada bing, bada boom, you're done. The idea behind that is the ease of setup and robustness. There's less points of contact. Instead of having the decoder plugged into an EQ, into an amp, into a speaker, and all of the uncertainty that comes from that, to some extent, and some of the possible losses that come with that, but largely the uncertainty of reliability and connection quality, we just dumbed that down to single RJ45 crimped onto a Cat5 or Cat6 cable, plug it in, and you're done. Now, for the record, each one of these speakers does still have an analog input. If you don't want to connect it with a digital feed, networked, you can still take the output of your analog source. All surround decoders have analog outputs, even though they're digital processors. You can take those analog outs and go directly into the speaker with preferably an XLR balanced cable, if you want. So if you look at the connection plate on the speaker, you'll see an XLR connector, you'll see an RJ45, actually an input and an output, because you can, if you want, you can daisy chain the networks
Daisy
together.
chain them, right.
And then you'll also see an XLR for AES EBU. That's a professional version of SPDIF, the regular digital coax that comes out of consumer products. There's a pro version of that. So choose how you want to hook it up. We recommend the RJ45 because it works mo better.
And it avoids any kind of problems like reversing the phase, reversing the connectors of the speakers, all that stuff.
And if you're trying to do a high-end system, it means you're doing active monitors. And there are other companies in the field who do this. And now you're running, like 3 separate speaker cables, one for the bass, mid-range, one for the tweeter. Now, there's that many more possibilities to get something crossed, and I've seen it all. We've seen it all. It's unbelievable. It's hard to get it right. It really is. There's just a lot of connections. This just takes it all. Just don't deal with any of it.
Right. That's another point, though, I wanted to make sure we made here, was that these speakers are tri-amped. Each driver basically has its own amplifier, right?
Yeah. In the beta, the 2 woofers, in both of these speakers that we've shown here, the 2 mid-range mid-woofers are in parallel. So that's one channel of amplification. And in the larger speaker that uses the 12-inch upper woofer, I guess, because neither of these speakers are really full-range loudspeakers. They're 80 hertz boxes made to go with a subwoofer for a complete, a full bandwidth audio system. So we're dealing with and when we had those specs of like 120 dB, 115 dB, that's only for the portion of audio that they are made to handle. You add enough bass to keep up with that, and that number is going to look even higher.
I have a little diagram of the amps and the speaker if you want to put that up, but this is a little block diagram of a system. Surround decoder would plug into our network adapter. Output of the network adapter through Cat5 or Cat6 would feed AES EBU audio and IP, and this red boundary over here represents a complete speaker, in this case the alpha, the 3-way. So this little block over here receives the signals, applies equalization, crossover, delay as adjusted, partially at the factory and partially in situ. I love that. I speak Latin.
That's a great term, yeah.
In situ to tune the speaker to the room. It also has protection, and it also provides an IP addressing to the speaker. The output of that goes to, in the case of the Alpha, 3 amplifiers, one for the woofer, 1,000 watts over here, one for the mid-range, which is 500 watts, is shared across these 2, and one for the high frequency, which is only 250 watts. These amplifiers are also communicating back and forth with the digital processor, which is communicating out through IP to the world. So we can talk to all of this, control it through a computer in the room, through IP, and if this is actually on the network of the home or the post-production facility, wherever it is, and it's open to the outside world, like all what I call Internet of Things devices are, we can talk to this from our office. So if a client has this at home and says, I want to make sure my speakers are working, we can actually connect up to that and run some tests, some actual diagnostics, and see that this is all working, which is very cool. Moreover, these also have self-diagnostic tests that every 15 minutes are just verifying a bunch of different things that are crucial to say, yeah, it's all working. And if anything is out of spec, it sends an email to Manny's private email address 24/7 and tells him, hey, the left speaker has an amplifier that is overheating or whatever, whatever is going wrong. And so that's one of the things that makes the system a little bit kind of more progressive. I talked way in the beginning about one of our mission statements being to be a new school. And, the sponsor of this show, thank you very much, is a company that makes a little doorbell that can connect back to your iPhone and tell you somebody's at the door to either deliver your Christmas presents or rip you off. That's the way of the world. And the AV business is not even getting there. And we thought, if you can find out that somebody's at your front door to deliver a package or steal your package, wouldn't it be nice to find out that your speaker's not working, your sound system that you prize, that you love, isn't working? So we built all the same kind of Internet of Things, IoT, into the system. And that's partially why we recommend hooking this stuff up with the Cat5 so that we can then put it on the network, and then you can monitor it, we can monitor it. Whoever is interested in finding out how this thing is working at any given time can actually see that.
Yeah, and we can also affect calibration. So if a client were to call, say, what, I would like a little more surround, or it's just not quite bright enough, or anything like that, we can.
You can just do it remotely and let them tell you. Here's a test tone. Here, I'm tweaking it now. What do you think? Oh, yeah, that's good. That's good.
If they could do it that way, that's right. So there were a couple of comments on the chat room that I'd like to spend a minute just clarifying.
Sure.
It's a 12-inch woofer, and those are 6.5-inch mid-range drivers, and it's a 1-inch throat compression driver, just for the record.
Okay.
There's no ports. They're all sealed boxes. They go down to 80 hertz. And then what was the other thing about volume control? All right, so there's this issue about how do you affect volume. And no, we do not send go louder signals or go softer signals. The volume is manipulated in the digital data stream at the surround processor usually, or if it's analog.
So in essence, in the digital data stream, you are sort of sending it a message of go louder, go softer, right?
No, that would be metadata that would be on top of the digital audio. They're actually processing. What happens is the processor manipulates the data so that it's lower in level, and it works very, very well. You can argue that you're losing a few dB of signal to noise, but it's a theoretical problem, not a practical problem.
Right. SoundPro69 in the chat room asked another question I wanted to make sure we got in here. Since the acoustic power decreases in the room for the high frequencies much faster than for the low, wouldn't it be enough to have an even omnidirectional dispersion in the lows and more directive tweeters, like a Walsh driver with a high crossed over tweeter? How much is the waveguide influencing the unwanted bouncing of high frequencies?
Well, here's the thing. You don't want to damp the high frequencies from bouncing around your room. We could do a whole show just on this particular, niche of acoustics, but that's the whole point. Is there's a misconception that somehow the room is the enemy, and we have to design loudspeakers with narrow dispersion so that we don't interact with the room. And every test that's been done basically says no. The reality is, flip that idea on its head. You need good broad dispersion to as high a frequency as you can get. You do not want to over damp the high frequencies out of the room with acoustical treatments, and the treatments that Tony specifies as part of PMI are made to actually be somewhat reflective at the highest frequencies and then absorb more in the mid-range and low mid-range, and then use bass absorb, because you need to keep that energy in the room. The room is not your enemy; it's your friend. You need it, right? Humans have an echolocation mechanism almost as good as a bat's, right? We don't have the sonar. We don't have the chirping side of it.
We don't have those high frequency, ultrasonic frequency echolocation.
No, we don't. But no, within our passband of our hearing, our ears, we have extraordinary echolocation. I shouldn't really call it echolocation, but perception of direction, particularly horizontally, and walls, and people who are blind have extremely acute hearing because they develop the sense. Most of us don't have to develop it. I heard a story once of a blind guy in India who could ride his bike around Calcutta because he could hear a stop sign. I don't know if that's really true, but we really do have extraordinary ears. And so those reflections, if they are not filtered, actually provide good data for the ear brain to use to help localize the loudspeaker in space, which is what you're trying to do. That is the source of sound. So, and to add richness to the uncorrelated data in stereo and surround setups as well.
Well, it's all very fascinating. And I'm afraid we've run out of time. I'm so sorry to tell you that. Can you imagine? Listen, thank you so much for being here. That's Anthony Grimani and Manny LaCarrubba of Grimani Systems talking about their incredible new speakers and home theater systems, which they sell. One last question I should ask you. This type of system ain't cheap, is it?
No. If you want it all, I mean, we have a system that really can compete on sound pressure levels with any PA speaker in its class that will go toe-to-toe with any audiophile speaker you care to put it up against. Absolutely, and that's just very hard and expensive to do. So what are we talking about here? I mean, just ballpark numbers. Is that something you care to get into, or would rather avoid?
Sure. So our the complete, what's called Cinema One, which is a complete sound system, not just the speakers, but everything you need to produce sound into a private screening room up to 1,200 square feet, if you want, a big room. So you may have a room with 20 or 30 seats, 40 seats. That whole thing, including the design services and the acoustic treatments and the calibration, all the speakers, the subwoofers, everything has a retail of $300,000, which, yeah, thank you, it's expensive. It's good. Now, if you look at the competition, you look at other people out there, there's plenty of other companies that do all the same, that charge the same amount of money for a lot less value, and that's the issue. The system, yes, it's expensive. It's as expensive as other products on the market. It just gives you a whole lot more value, is a lot more robust, sounds better, works all the time, and is very new school. The smaller package for rooms around 600 to 700 square feet, so 30 by 20 rooms, maybe 2 rows of 5 or 6 with maybe a bar row at the back, that has a full retail, including design and including acoustics, including calibration, of $200,000.
So we're talking 6 figures here, and
absolutely.
that's I mean, for a major home theater installation, that seems. It's expensive, as you say, no question.
It's not expensive, it just costs a lot. I mean, really, it's not a luxury good. It's not like a Gucci handbag or something. It really costs that much if you want that performance. But anyway, I'm sorry to interrupt.
Right, and
that's quite all right.
So some of the reasons for the expense, of course, are very, very high quality drivers, high quality amplifiers, high quality construction. We're not putting a whole ton of margin. I think that's what when Manny thinks of luxury goods, he thinks of something that is expensive because there's a brand and some bling associated with it. There's no bling here. To make these things work the way they do and make them be as reliable and quality driven, you start with very, very good componentry, and you carefully assemble it and carefully tune it, and you do all of that in a handcrafted and careful way right here in America, and that's the price.
Yeah. Well, and from what I've heard, it is absolutely worth it. If you've got that kind of scratch, you definitely want to check this out. And the place to do that, of course, is GrimaniSystems.com. Anthony and Manny, thank you so much.
You're very welcome.
Thank you very much. Thanks, Scott.
You bet. Now, you can always find me, of course, at avsforum.com. You can email me at scott@twit.tv, and you can follow me on Twitter at htgeekscott and at avsforum. You can always find previous episodes of Home Theater Geeks right here at twit.tv/htg. and on our YouTube channel, youtube.com/twit Home Theater Geeks. Next week, my guest geek is scheduled to be Dan Wiggins. He's the CTO of a new audio company called Stark Sound. And I heard their stuff at CES just last month, and I was very impressed by that. They do speakers, they do amplifiers, so it's going to be a 1-2 punch here for audio topics here on Home Theater Geeks, so I do hope you will join me for that. Until then, geek out.